Hello everyone, this session we goes with the mathematical induction. First is the concept why we need to learn mathematical induction. Because we need to approve, we need a method to approve the formula is right. So we need the ways to prove. This way is called mathematical induction. But if you ask me, is this the only way? I say no, they have other way. Right now we learn about this. So, let's see the definition. If a statement is true for the natural number n equals to k, then it will also be true when k plus 1, n equals k plus 1. And of course, the statement when n equals to 1 is true. So, simply speaking, that's what I'm writing. If you want to prove a formula is right through the mathematical induction, you first approve the first step. If the first step, if A0 or A1 is right, approve is right, and then you just assume there's the numbers n. Okay, the k is right, k step is right. Assume is right, and then you approve when it's go to k plus 1. The result is same as the formula. That's if you can approve the n plus 1 to meet the formula as well, so which means it can apply for all the natural number. You may ask me, how did we resolve that induction, mathematical induction? I don't have idea now, but maybe you can also check, because for mathematics, for whatever, any kind of science or subject, always ask yourself the how and why. That's definitely helpful for you to grow, as well as to the interesting is very important for you learn something. Okay, so since we all know the strategies, let's prove it. Okay, so we have two examples to prove this. This one we learned already, right? 1 plus 1 square plus 2 square and n square. Let's we learn the sequence, right? A series, and the formula is n times n plus 1 times 2n plus 1 equals to 6. Over 6. That's the formula. So now we use the mathematical induction to prove it. Okay, so how to prove it? So we follow the step. The first steps, we choose n equals to we choose n equals to 1. Okay, so n equals to 1 on the left side is 1 square. Let's see if it's equal to right side, huh? So this is 1, n equals to 1, and 1 plus 1, then 2 times 1 plus 1 divided by 6 is exactly equals to 1. Am I right? So when n plus 1 is proved right, so assume n equals to k, we meet that. Meet what? K times k plus 1, then 2k plus 1 divided by 6, right? It's equals to what? 1k squared, right? Then need to prove when it's n equals to k plus 1, square, the function should be like what? Here, huh? K should change to k plus 1, right? K plus 1. And then k plus 1 plus 1, k plus 2. And then 2k plus 1 is 2k plus 2, and be 2k plus 3 divided by 6. This we need to approve. Okay, so let's see, huh? Based on this one, we can get what? We can get, because we already assume it is it's right? So 1 square plus until k square is k plus 1, then 2k plus 1, and divided by 6, then plus k plus 1 square. Okay, so what we need to do, we need to approve for this form, these two items will be finally equals to this one, right? Right? This is by right formula, right? Because this already assume is right, and then it's plus 1. If this one is equal to this one, then totally damn, the proof is right, right? So let's see how to prove that. So definitely this have to be divided by 6 by both sides, right? Or times 6 by both sides. So we can have the common factor 6. Let's do it, okay? So k plus 1, 2k plus 1, 6k plus 1. Okay, so what's the common factor? K plus 1, right? So k plus 1, then is what? Right? Then is k times what? 2k plus 1, right? And the plus what? 6k plus 1. Am I right? Then let's simplify this. Is 2k squared plus what? Plus k plus 6k plus 6, right? So this will be equals to what? 2k squared plus 7k plus 6. Okay. Can this be written as k plus 2, 2k plus 3 for this one? Yes, of course, right? It's exactly right, right? So we just copy this one down. So k plus 1 then divided by 6. So let's go back to see exactly, wait, this is not exactly same as what we want to prove, right? So we approved. Yeah. So the second one, let's try to prove. The second one is here. Let me double verify. This is the 2 to the nth power. If 2 to the for every integer, when n greater or equal to 5, the 2n should be less than n prime. So let's first is to prove uh, let's do a proof n equals to 5. Okay, so when n equals to 5, uh, uh, 2 to the 5th power is 32, right? And then 5 prime is 120. So definitely this is smaller, right? So if k to the 2 to the kth power less than k prime, then prove what? Prove 2k plus 1 less than k plus 1 prime. Sorry, prime, right? So what we need to do is we just write in here, right? So 2k plus 1 is equals to 2k times 2, right? And the right side is k plus 1 prime can be k prime times what? K plus 1. All right? So let's compare. 2k, k prime, we already have 2k less than k prime, right? And if this number is less and then times 2, and 2 is 2 less than k plus 1, definitely, right? Definitely k should be over 5, right? So definitely to approve. So should be exactly. So we can prove this one. So anyway, this is a mathematical induction. In fact, the mathematical induction can prove a lot of things. Now we already have example of inequality, or we have an example of the formula, so or equation. So there are many other ways you also can to prove a different kind of the formulas. So please do exercises at your back end. Okay, so thank you very much to join this session.